This is some function that you're looking at, profit, whatever it is, cost, revenue, whatever. We have a lot of information now. We have, what was our local minimum? Where did it happen? Where did we have a local minimum? It was X was what? Negative 3.7? Okay, so let's go to our graph here. Here's 0, here's negative 2, here's negative 3, here's negative 4, so negative 3.7 is about here. And if you come down and look at this graph, voila, look at that. We actually found where that happened, right? And then we had a local maximum where? Like 0.366. So here's 1, here's a half, like 0.366. There it is. We found that point, didn't we? If you look to the left of this point, we are going down, aren't we? Between here and here, we are going up, and then over here we're going down. Do you see that? We know all that already without the picture. I'm just showing you that it matches what's happening in reality. Now, the concavity was smiles and frowns. Where did we have a concavity change? Where was that? Negative, was it negative 2/3? Negative 5/3? Negative 5/3 is about negative 1 point something like that, okay? So if we go to negative 5/3, it's about right here, and I want you to look at this point right here. That's our inflection point. What were we supposed to be doing to the left of that inflection point? What were we supposed to look like? A smile. And what about to the right? A frown. Do we look like a smile to the left? Yes. Do we look like a frown to the right? Yes. Okay, so we have a lot of information about this graph. Now, I want to discuss a little bit more about this inflection point. There's something like you might be thinking, who cares about the inflection point? But it's actually a critical point in a business model. And let me show you why. I'm going to kind of redraw that. Let's say that we have a function where we have increasing, smiling, right? And then all of a sudden, we're still increasing, but we start to look like a frown. Okay, that is an inflection point, yes? We're going from a smile to a frown. In business, this point right here has a special name. Let me tell you what's happening first, or show you, illustrate, and then I'll tell you what it's called. All right, so let's say that this represents our revenue, okay? Money coming in. So right here, if I look at the slope of the tangent line, it's going up, right? It's pitched up. So is revenue coming in or going out? Revenue is, we're getting money in, right? Because my slope is positive? Okay, so I move to the right. Is money still coming in? Yes. Was it coming in faster than it was back here? Yes. Why? Why is it faster here than it was here? It was steeper, right? Steeper means I'm getting, the change in revenue is faster. It's more money coming in. Understand? Here, faster, right? Faster. Money's coming in faster. Now, when I get to this point and I start moving this way, do I still have money coming in? Yes. Yes. Is it coming in as fast as it was back here? No. And now I keep moving to the right. Am I still having money come in? Yes, but not as fast, right? So this point right here is called the point of diminishing return. The point of diminishing return. Point of So it's kind of like, look, at this point, you're still gaining, right? You're getting a return. You're still gaining. But as you start to move to the right of that point, your gains start to diminish. It's less steep, less steep, less steep. And the only way you can see that happening, or the only way to identify that point, is to look at where the second derivative goes from a smile to a frown. That's how you find that point. Does that make sense? I hope that kind of does. All right, so we're gonna focus our next class on doing more. Actually, we haven't done any word problems. We're going to be applying this to word problems. Okay? That sound like exciting stuff to you? Of course it does. I'm going to cut you loose a little early today, but here's what I need. We're not leaving yet. If one person could get a sheet of paper and pass it around for a sign-in sheet, please. Your homework for this section, 12.2, do all the problems that are listed except do not do 41. 41 is another one of those sign charts. Now for 12.2, skip 41, skip 85, 83, 85, and 87. So for 12.2, skip 41, 83, 85, 87. We're never going to do 41, and these are word problems that we will discuss next class, so after next class you should be able to go back and do those, all right? You can do everything else. Now, while the sign-in sheet's going around, I thought that I might share some useless information with you. Do you like random useless information or no? This isn't useless, but I think it's an interesting little story, and I'll try and finish it. I'll try and finish it in 5 minutes. Okay, so there's a story that goes with this. That there's this very famous mathematician who, when he was in kindergarten, the teacher told the students, hey everyone, I would like for y'all to add up the first 100 numbers, like 1 plus 2 plus 3, all the way to 100. Right? This is kindergarten. And this was back in like the late 1800s. And so the idea was that the teacher was going to give these little kindergarten kids some busy work, something to kind of keep them busy so the teacher could go get on his phone and like text whoever or whatever, right? No, this is a long time ago. I don't know why. I want to give them something busy to do. So the story goes that this little kid, who later became a great mathematician, within a few minutes of being given this assignment, finished doing something, and then they used to have like little chalkboards. Instead of like paper, they would have little chalkboards. So he like wrote something down, then he turned it over, which was a sign that I'm done, and then he sat there very quietly and obedient, because they used to have discipline and stuff back then too. So he just sat there, and the teacher kind of walked up to him, turned his little slate tablet over, and the kid had written n times n plus 1 over 2 written down on this little tablet. And so the teacher looked at that and kind of got a little irritated and said, who showed this to you? This formula at that time was known. Okay, so this wasn't like an unknown formula, but the kid had it written down. So the teacher's like, who showed it to you? And the kid was like, no one showed this to me. Like, I came up with this formula, and the teacher didn't believe him, right? So the kid went on and showed the teacher how he came up with the formula, and I'd like to show you how it's done, all right? And I think let's just see, okay? All right? So let me try it with this. I want to add up the first 100 numbers. So I'm going to add one more thing to this. Let me add a couple of the ones that would be here. 97, 98, 99, and 100. By the way, I should point out that the n here means if I wanted to go all the way out to n, like this is like if you want to stop at 100, just put 100 here and 100 here, and then figure out what this is. If you want to stop at 4, just put a 4 here, and that'll give you the sum. You can check it yourself on your own time. All right, here we go. Yes? Ready. So the kid goes, all right, I'm going to call this S for sum. Okay, so this is what the kid's explaining. I want to call this sum S. So we're trying to find S? So he said, all right, I'm going to write S again, but I'm going to write it backwards. Okay, so what would the last number be if we wrote it backwards? 1 and the one before that? And the one before that? 3 and then back, right? Okay? So then he said, all right, I'm still trying to find S. What if I add these two rows straight down? What happens? So what's S plus S? No. What's S plus S? Adding. Just two of them, right? Two S's? So this would be 2S. That should be equal to these two added together, right? Okay, so watch the way I'm going to add these. What's 100 plus 1? 101. What's 99 plus 2? 101. What's 98 plus 3? 101 again. In fact, if I keep doing this, these are all 101s, aren't they? All the way down, even when you get to the last one. 101. 101. 101, right? Agreed? Now, critical question here. How many of those are there? Well, let's see. There's one of them, there's two of them, there's three of them, 4, 5, 6, 7, 8. How many are there? 100. There's 100 of those, right? There's 100 of those. So as a quick reminder, if I had 5 plus 5 plus 5, we can write that 3 times 5. So when you write addition over and over, we can use multiplication to represent that, right? So if I have 5 plus 5 plus 5 3 times, it's 3 times 5. So if I have 101 added up 100 times, I can rewrite that as what? 100 101s, right? So notice this pattern that if we go out to 100, we're going to have 100 101. So this number isn't this number always going to be one more? Yes? But also notice this was twice as much as what we wanted. So if we just divide by 2 and divide by 2, then you have some form that looks kind of like that formula over there, doesn't it? Okay, so I lied to you a little bit. This is actually not the way Gauss, his name was Gauss, sorry. This is actually not the way he showed it. I just showed it to you this way first because it helps make the leap. So this is actually what he did. He said, I'm going to add up 1 plus 2 plus 3 all the way out to n. Okay, so he actually used n. And then he said, what's the number right before n? Well, it's whatever n was minus 1, right? And then what's the number right before that? Well, it's whatever n was minus 2. So if that's 100, that's 99, right? Okay, so if you write that backwards, this is n, right? This is 1. This one right next to it would be n minus 1. The one right next to that would be n minus 2. And then forever, right? Down here, not forever, but to 2 and then 3. See it written backwards? Yes? Now, when you add straight down, what do you get? S plus S? 2 S's equals, now look at this pattern. N, you add these two together, n plus 1, right, is n plus 1. What's n minus 1 plus 2? N plus 1 again. What's n minus 2 plus 3? N plus 1 again. N plus 1, n plus 1, all the way to the last one, n plus 1. So I have n plus 1 added up, right? How many of them?
100.
Not 100. N of them, right?
Oh.
1 of them, 2 of them, 3 of them, 4 of them, n of them. So this is n plus 1s here. But that's twice as much as we want. So divide by 2, and you get this formula right here.
So what did he plug in the formula?
He didn't plug in. He used n.
Kindergarten.
Kindergarten, yeah, we'll get to that in a second. So actually, let's see. Like, I call this the birthday function, or the spanking function. So look, I said spanking. Let's say that you're 20 years old, right? Say you're 20 years old. And let's say that you've had a spanking for each birthday you've had, right? Or if you don't like that, you've had a candle on each of your cakes, 1 candle, then 2 candles. How many candles have you ever, had in your whole life, right? If you're 20 years old, then this is going to be, according to the formula, this is n, right? So according to the formula, it's 20 times 21 over 2. So what is that? Let's just do 20 divided by 2 is 10. 10 times that's 210. So if you're 20 years old, you technically should have blown out 210 candles so far. If you know what I'm saying?
Yeah.
Okay. What do you think? Kindergarten.
What happened at the end of that story? What happened then?
Well, he obviously went on to do some brilliant things in mathematics, right?
I'm talking about right then and there, like what happened? What you think
I think that they recognized that he was gifted. So I like to show this story. I like to share this because I think this really shows like the difference between genius and like just everyday people. Like I'm not a genius. I'm just an everyday person. I learn math by working hard and trying to understand it. This is a gift, right? This is a gift. How does somebody at that age understand to break that problem down? Did you all follow this pretty much?
Yeah.
See, that's what genius is. Genius takes something that looks completely unachievable, right? Find the sum of the first n numbers. How, right? And turns it into something that almost everyone can follow. It's just that leap to it is what is amazing. So, okay, y'all have a good weekend, right? Do your homework.